Today we are talking about compound events. Sample space is the set of all possible outcomes is your sample space. One of the big things is with this is you need to keep your thinking organized. Sometimes it's a little bit difficult, but you need to be able to think that organized. And one way that is suggested is tables and tree diagrams, like you will see. We are talking about pizza. All right, so we have two different options here for crust. We've got a thin crust and we've got a stuffed crust. And then we've got four different options for style of pizza, or the toppings that you are putting on it. We've got Hawaiian, Mexican, pepperoni, and veggie. So our sample space is going to be all of these outcomes right here. For the thin crust, we have a thin crust Hawaiian. We have a thin crust Mexican, a thin crust pepperoni, and a thin crust veggie. So there's four different outcomes just within thin crust. Then for our stuffed crust, we've got a stuffed crust Hawaiian, a stuffed crust Mexican, stuffed crust pepperoni, and a stuffed crust veggie. So our sample space is this right here. We have got 8 different outcomes. Eight different outcomes possible for our sample space. If we were to have, let's say, a hand-tossed crust, we would actually have 4 more options here. We'd have hand-tossed Hawaiian, hand-tossed Mexican, hand-tossed pepperoni, hand-tossed veggie. And then we would have 4 more, so we would actually have 12 outcomes. All right, another way to find the total number of possible outcomes is to use the fundamental counting principle. Basically, it says an event M, with a capital possible, has a possibility of M with a tiny, has M possible outcomes. So event M has M outcomes. Okay? Event N has N outcomes. Okay, so the number of possible outcomes of M followed by N, M happens first, and then N happens, is M times N. If we look back here to the pizza example, we had 2 possible outcomes here, thin or stuffed, and we had 4 possible outcomes here, Hawaiian, Mexican, pepperoni, and veggie. So 2 times 4, if we multiply there, we get our 8 possible outcomes. If, like we talked about, we had that third one here, the hand-tossed crust, we would have had 3 times the 4 toppings, and that would have given us 12 possible outcomes. All right, so you multiply the first set of outcomes by the second set of outcomes, and you will get your total outcomes. All right. One important thing, this fundamental counting principle can be applied to more than one. So if we go back to this example here about the pizza, and if I add one thing here, if I say, okay, we also have cheese, and there is the regular amount of cheese, or there is extra cheese. So we've got 2 different options there. So we choose our crust, got 2 there. We choose our toppings, we've got 4 there. And then we choose our cheese, and we've got 2 there. So that's going to be 2 times 4, which is 16 possible outcomes for that event. There was a third event there of what kind of cheese you would like. All right, so find the total number of outcomes of rolling a number cube and flipping a coin. So first we're going to roll our number cube. Then we're going to flip our coin. What are our possible outcomes? So we've got a 1 in heads and a 1 in tails, 2 in heads, 2 in tails, 3 in heads, 3 in tails, 4 in heads, 4 in tails, 5 in heads, 5 in tails, 6 in heads, 6 in tails. So we have 2 outcomes here, and we have 6 outcomes here. So 2 times 6 is equal to 12. And we found 12 different possible outcomes by making our table there. I don't care if you use a table. I don't care if you use the fundamental counting principle. I don't care which method you use as long as you understand it and you can explain it. All right, so the 12 possible outcomes here. How many different outfits can you make from the t-shirts, jeans, and shoes in the closet? Okay, so we have 4 t-shirts. Sorry, we have 7 t-shirts. We have 4 pairs of jeans, and we have 3 pairs of shoes in our closet. So 7 times 4 is 28, and 28 times 3 is 84. 84 possible outcomes. Because we multiply our number of shirts times our number of jeans times our number of shoes, and we get 84 possible outcomes. All right, so a compound event consists of two or more events. That's what we've been working with, is a compound event. Something happens and then something else happens. So it's 2 or more events, and it's really within a single event. So it's 3 things within a single outfit. All right, so the probability of a compound event is the ratio of the number of favorable outcomes to the number of possible outcomes. So let's try this one here. In example 2, what is the probability of rolling a number greater than 4 and flipping tails? So our total number of outcomes was, if I remember right, 12. Let's go back and check. Yes, 12 possible outcomes. And then we wanted the outcomes that were greater than 4 and flipping tails. So greater than 4, we're talking up here, and flipping tails, we're talking right here. So, well, greater than 4, we are talking here, because it has to be larger than 4, cannot be 4. So we got 5 and 6, and then tails here. We've only got 2 options, 5 and tails and 6 and tails. So it is 2 are the favorable outcomes, and there are 12 possible. And if we simplify that down, it's going to be 1 in 6. It's going to be the probability of flipping 5 and tails and 6 and tails with the die and the coin. All right, you flipped 3 nickels. What is the probability of flipping 2 heads and 1 tails? So we already have this nice diagram here. This is if our first one is heads, and this is our first coin, this is our second coin, this is our third coin. So if our first coin is heads, our second coin has to be heads or tails. And if our second coin is heads, our third one has to be heads or tails. If our second one is tails, our third one has to be heads or tails. So we are looking for 2 heads and 1 tail. This one is all heads, heads and 2 tails, heads and 2 tails, heads and 2 tails, all tails. So we have how many possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8. And then we have got 3 that are 2 heads and 1 tails. Now some of you would tell me that these ones here, they're all the same. It's 2 heads and a tail, right? So that's only, if these ones are the same, and these ones are the same, because the orange ones are 2 heads and 1 tails, and the purple ones are 2 tails and 1 heads, you would tell me they're the same. But they're not the same, because it matters. This is coin 1, coin 2, and coin 3. It matters which one does which. So those are not the same outcomes. So we have 8 total outcomes, and 3 of them are 2 heads and a tail. That is everything you need to know about compound events. Good luck.